All right, kiddos, this is 6.12, graphing the standard form. The only lesson or section that we're focused on right here is 12.2. We refer to these as transformations, especially in Algebra 2, and we're going to be talking about it in terms of quadratics. So your first quadratic, if my pen will work, come on, there we go, is this. So that's our parent function. And I went ahead and typed it into Desmos that you can see over on the right side of the screen. Now, one of the things that they want you to do is they want to go ahead and change something involving your parent function. Again, your parent function is the x squared that you see in Desmos. So they want you to go ahead and try adding a 5 to the x squared, a 10, a negative 3. Just add or subtract any number after the x squared in Desmos. So go ahead, that is for you. Go ahead and do that. All right, so after you've done that, what did you notice? When you added a number, what direction did your parabola go? Number two, or I'm sorry, and then for number one, if you subtract a number, what do you notice? What direction does your parabola uh, shift? All right, where does it go? All right, number two is now saying let's go ahead and multiply x squared by some number in the front. So go ahead on another line, instead of just doing x squared or y equals x squared, do 3 times x squared, do 7.5 x squared. Um, you know what? Even for another example, go ahead and try multiplying by a fraction. Um, oh, looks like they already do that in number four, so I'm thinking ahead. Never mind. All right, so go ahead and try that in Desmos and see what you get. Okay, so what did you notice about the parabola? How did it change when you multiplied the x squared in Desmos? And again, hopefully you're doing this in Desmos. So have to use Desmos for this lesson. All right. It's mostly just plugging it into Desmos and voila. All right. Number three, what if you're multiplying by a negative number? So negative 1 times x squared, negative 4 times x squared. What do you notice when you do that in Desmos? And then number four, hopefully you guys were doing 1 through 3. Number 4 is multiplying x squared by negative 1. Or, I'm sorry, not negative 1, by a fraction. So they want you to use a fraction. So, for example, what if you multiply 1/2 times the x squared? What if you multiply by a negative 0.25 or a negative 1/4, really, to x squared? Okay, so go ahead. Make sure you've done all these before I give you away some inclinations of what your solutions are. Make sure you've done all this, or try to at least in Desmos. Okay, so here's your solutions. For number one, okay, I'm going to have to use the Desmos here. So in number one, if you added a 5, what direction did you go? So hopefully you were like, here's x squared plus 5. What'd you notice? No. What if they did y equals x squared plus 10? Boom. Where, what'd you notice? And then what'd you notice if it was instead of plus 10, it was minus 3, like the other example? So in your own words, how would you describe that? Okay. Now in algebra or in mathematics, we would call that a shift, a vertical shift, up or down, depending on how many units. So the x squared plus 5 is a vertical shift up 5 units. Your outputs are all increasing by 5. But y equals x squared minus 3 is a vertical shift down 3 units because all your outputs now are down 3 units. All right, and number two, if you tried 3x squared. What do you notice? You tried 7.5. What'd you notice? Okay. So in algebra or in mathematics, we would call this a vertical stretch. So everything is being pulled up or down like a rubber band. Okay. So everything gets multiplied by a certain magnitude. Gravity is like this. So for example, 7.5 would be a much higher gravitational pull for a much larger or denser planet as opposed to 3x squared. Okay. So number three, they said to try a negative x squared, right? What do you notice? They told you to use a negative 4. Did you notice? So this is actually what we call a reflection. So the parabola is actually reflecting across the x-axis. And just like with number 2, the greater the coefficient in front of the x squared, the greater the stretch is. All right. So you're still getting that rubber band pooling aspect on a vertical. Just yes, it's reflected, but it's still negative 4. So that's still, 4 times greater than just negative 1. Does that make sense? All right. And um, 4. Number 4 is a little bit more interesting. They asked you to do 1/2. What did you guys notice? Right to your parent function, right? And then they asked you to do negative 0.25. Which is the same as saying negative 1/4. They're getting wider, right? Does it look like the parabola's getting wider? So the negativity still does the reflection, but instead of stretching, right? It's getting wider. Now, in algebra, in mathematics, we call that compression. So you're actually pressing down, you're compressing your outputs. So your outputs are becoming less than they normally would be. For example, 1/2 times x squared. Now, your outputs are all basically just half of what they formerly were. Um, and that's basically what we're talking about is the compression idea. All right, so that's the end of the lesson. You guys have a wonderful day and continue on to lesson 14. Bye.